All right. Last talk of the day, best talk of the day, right? So you guys are either waiting out traffic or you're really interested in SIEMs. But either way, happy. Hopefully we can answer your questions and cover some good content here. So introductions, my name is Fred Fry. I'm with Snap Attack. We do detection engineering as code for validation purposes in SIEMs. So we have luckily we have 15 EDRs and SIEMs in our lab, so we've gotten a chance to play with all of them. So this talk, we're gonna talk a little bit about current SIEM technology, about the evolution of SIEMs, about how data lakes are evolving to try and compete, and then we're gonna talk a little bit about the future and some interesting stuff. All right, that's what I think I just said. All right, so brief history of SIEMs. So SIEMs are actually 2005, Gartner coined the phrase SIEM, right? Who here knows what SIEM stands for? Yeah. What's that? Yes, exactly. All right, give her a hand. Good job. All right. Quite honestly, I didn't know what SIEM was for the longest time. I was like, I don't even know. So I had to Google it. But yeah, no, my career, I started as a red teamer. So first 16 years, I was doing a lot of offensive stuff. 2014, switched over to the blue side and learned a bunch about SIEM technology, writing detections to look for hacker activity. So I'm kind of traded in my red card for a blue card and have a lot of fun since. So the history of SIEMs, right, 2005, the two big SIEMs that really hit were ArcSight and QRadar. We're not gonna talk too much about the history, but those were the two major players in 2005. And back in that day, it was really around single pane of glass, data aggregation. I have AV alerts, I have firewall alerts. It wasn't really a data lake. You weren't sending raw telemetry, it was more alerts and how do you prosecute those alerts through like a ticketing system, look at them, dismiss them, et cetera. Around 2010, there's a big shift. So there's really three major shifts that we'll talk about. The next major shift was really when Splunk kind of came to town. So Splunk was actually founded in 2003, which predates SIEM technology, but it didn't actually start as a SIEM, right? And it really didn't even gain popularity as a SIEM or even have the proper functionality. And we'll talk about the functionalities of SIEMs. But it didn't even have that until around 2010. It started, topping some charts and becoming very popular. And then I guess that shifts us into the third phase, right? The third phase is the phase we're in, which is really around raw telemetry data. Data has been exploding, right? Just absolutely massively exploding, and cloud, right? So, when you shift to the right, you have a lot more data, and you need to prosecute that cost effectively. And so we'll talk a lot about that, but driving a lot of this is cost effectiveness for customers at enterprise levels. I have some customers that have 25 terabytes a day of ingest. We also see some customers spending upwards of $10 million a year. So cost is a real big driver when you're talking about SIEM technology for the enterprise. So that's really ushering in like the third wave, which I feel like we're in right now, which is cheap data storage, cheap and distributed federated querying against cloud data, which is a lot more effective. Okay, so we talked about some different generational gaps. The other thing is in the second generation, we started seeing certain technologies that we thought were whole markets become folded into the SIEM as features. And I think we're gonna continue to see that. And whenever there's a new technology out there, it's really shiny, innovative, but then there's maybe a down market. Those companies can be acquired into larger companies. Customers are always looking for seamless integration. That was a joke that I didn't mean. Seamless integration, right? They want things to work well with each other. So when there's down markets, that's the consolidation time period. And when there's up markets and a lot of investment, that's when you have a lot of innovation. And so there's been different ebbs and flows through the years. But yeah, EUBA, which is like end user behavioral analytics, right? Seeing the pattern of life of certain users, memorizing what they normally do, and then finding deviations of that. That now is, for the large part, like built into SIEMs, either through detection logic and some acquisitions. Same thing with SOAR. SOAR was really, really popular maybe 2015. Now we're largely seeing SOAR automation, right? Like when an alert comes in, how can you automate the first couple of steps of that? We're seeing that being rolled into a lot of SIEMs today. All right, so the hype curve. This might be a little bit tough to, that's right, I have a microphone here. Maybe you can still hear me? All right, cool. So yeah, so the hype curve. Hype curve is really talking about, when it first starts off, everybody's like on this roller coaster ride up. We're really, really excited. It's a brand new technology. Everybody's really excited. And then it doesn't deliver because innovation isn't always keeps up with demand of the hype, right? So then we go into this like valley of despair, right? The valley of despair is where people that thought this was gonna cure cancer are disillusioned. It still is an amazing product probably, but it's just maybe overhyped, right? And I think in cybersecurity, I think we're very, very in tune with overhyped products, right? I think there's quite a few there. And then if it makes it out of that tranche of, holy cow, this is the best thing, it's not really doing everything that I want. If it can make it up out of that plateau, that's where they call it the slope of enlightenment and plateau of productivity. So this is a Gartner slide that we're pulling in here, but I just wanted to point out two things. SOAR, right, kind of died in the tranches there, and it didn't die, it just got absorbed into SIEM. But two of the prominent things that did make it out that everybody's using every day very consistently is SIEMs and EDRs, right? And at a point, we were wondering if like SIEMs were gonna go away. So there's this continuous cycle of like, this is gonna kill SIEMs, right? XDR is gonna kill SIEMs. EDRs is gonna kill SIEMs. Like, the point of this talk is they're not going away. They're gonna evolve. The definition's gonna expand, but they are absolutely critical in day-to-day business and will increase, but will change. And we'll talk about that. All right, so RSA. How many people were at RSA this past year? Okay. All right, only one? All right, okay. So RSA was a feeding frenzy when it comes to SIEMs. It was absolutely madness, right? Like absolute madness. There was a lot of crazy moves that were not on my bingo card for 2024 that happened, right? So I'm not gonna read them all, but right, Cisco acquiring Splunk, right? If you've ever seen the funny meme, it was like, junior analyst at Cisco says to re-up the Splunk license and they accidentally buy Splunk, right? Like, but yeah, they bought Splunk. CrowdStrike is now coming out with a SIEM to market, right? They acquired Humio, and now they call it LogScale. Well, now they're calling it Next Gen SIEM. All three are the same thing, just next evolutions of it, so if you get confused by that. We have Palo Alto doing an interesting purchase, right? We mentioned QRadar was one of the first to the market. They actually bought all of the assets and all of the customers, most importantly, from QRadar. So they're gonna try and do a SIEM migration from QRadar customers to their SIEM, to Palo Alto's XOR or XSIM. So there's a lot of movement. The next slide kind of visualizes this. This is the Gartner Magic Quadrant. And if you see, there's a lot of red, right? There's a lot of red going on here. There's a lot of changes, right? Splunk, now Cisco. IBM, QRadar, now Palo Alto. Securonics was purchased by a PE firm, Vista. So a lot of things. Exabeam and Logarithm now are under the same roof. So there's a lot of consolidation that's happening, but they're all trying to compete. And raise your hand, because I was looking at this slide. This, oh wait, I think there's a fancy laser pointer. Okay, that. Has anybody heard of that SIEM? You have? Yeah? Were they? Okay. Excellent, okay. Awesome. All right, well, I learned something new. I saw this chart, put it on here, and I was like, I don't think I've ever heard of them. So I learned something new every day. So we talked about this, right? Summary of market trends, right? Convergence, consolidation is gonna be a big thing. Greater centralization of logs, events. XDR was the big thing, right? Around like, honestly, I think XDR was overblown. It really just means like we have logs from the network, we have logs from entity, we have logs from here. Let's standardize what we call an entity so that we can query and do joins across data, but that's super important. All right, so we're gonna get into the heart of it, right? Comparing and contrasting SIEMs with data lakes. So Data lakes, we're gonna focus on three main aspects, right? So three main aspects are the data layer, the analytics layer, and then the operational layer, right? So if you think about those three things a little bit separately, we'll do some compares, contrasts. These slides will be available, so if you wanna access these afterwards, feel free. Okay, so when we focus in on the data layer, right, like who wins? I gotta give it to the SIEM. When we talk about data ingestion is obviously way better at data lakes. The data lakes, when we talk about data lakes, I'm talking about non-standard SIEM data lakes. So we're talking about maybe Databricks, we're talking about Snowflake, we're talking about large S3 data stores. There's a bunch that is on a future slide, but they make data lakes make data ingestion absolutely easy, but where they kind of fall down is there's not a lot of standardization, right? So there's frameworks out there that are trying to standardize log field names, and it has not happened. Actually, I was a contributor on OSSEM, O-S-S-E-M. It was Jose Hernandez. He and I were really passionate about this a long time ago. We tried to standardize field names. It just doesn't happen. OCSF seems like it has a lot of traction behind it, a lot of huge companies behind it. We'll see if that gets traction, but.
Our site, started first with SAP and Leaf. They were the first to
Yeah.
try to do it, and
yeah.
didn't succeed.
Yeah, it is not for lack of effort, it's for lack of cooperation, right? Incentivization of cooperation is really tricky among big players. So indexing, fast indexing. So a lot of this really comes down to what are you looking to do? And I think we'll get to some of the conclusions at the end, but data indexing. Data indexing means, hey, not all data is created equally. I would like to query my IP addresses, my host names, my usernames, my command lines and parent processes way faster than something like the DLL hex in an inter-process communication call, right? Like that's just a lot, it's more of an expensive call. So you can trade off money for or data storage and indexing and processing for cost savings for compute for query time by like indexing certain fields that are more important to each other. Data enrichment. You absolutely, like if anybody's out here like skeptical, like I'm on team data lake, right? And you're like, I could definitely do data enrichment. Absolutely, you're right? You can do both of these things in both columns. It's just which one comes out of the box and which one do you have to put your own muscle in towards it. And feel free to disagree, honestly. It's totally, a couple of these I was waffling, right? All right, so the next layer, let's talk about the analytics layer. So we've got our data in, we've got it normalized, we have it stored, we have it indexed, fast index searched. But like talking about the analytics layer, now this is where my company shines. This is what we do every day. So this is kind of near and dear to my heart. We do detection engineering at I would say like at a software level, and we compile queries down to Chronicle, Yara L, compile it down to Splunk, compile it down to Elastic. So to us, we are actually SIEM agnostic for the most part, and I say for the most part, probably 85%. But what that allows us to do is to evaluate many different SIEMs and the efficacy of detections against these SIEMs in our labs. And one of the very interesting things is these data lakes and what role they're gonna play, kind of combining with this. So I mean, really, when it comes down to analytics, you can absolutely write some extremely powerful queries in data lakes, but we have some customers that have Databricks, Snowflake, things like that. The data is just not as standardized. So the portability from customer to customer, you have to home grow a lot of it. And so some of these big, large banks are absolutely finding the cost trade-off worth it to say, I'm gonna have a data engineering team, we're gonna data engineer this data, wrangle it into it, and we're gonna, the outcome is gonna be very, very, very cost effective, but we're trading that CapEx for OpEx value cost. Okay, let's see, operations layer. So the operations layer is like the layer above, right? So now you have your detections, now you have alerts. What do you do with these alerts? How much, also the engineering aspect of the SIEM, right? So how scalable is this? Recently we've had a couple of SIEMs that are not cloud native really struggle. So being cloud native, scalability with large data sets, that definitely goes to data lake. Another thing that goes towards data lake is maybe support and maintenance, right? Like you're not maintaining it, you're not patching it, you're not having to deal with that stuff. But when it comes to integrations and pre-built integrations, that's what the SIEM is built for. Okay, so let's get that stuff out of the way. So what future trends are we kind of starting to see? So we are starting to see some hybrid stuff going on. So these are what we would classify as like our data lakes. By themselves, they require a lot of batteries, right? Like, I mean, I have 3 kids. Every Christmas, it's like, Santa brings all these things, and I'm like, great, I have to put all of this stuff together. It takes hours and hours and hours. That's what you're gonna get with a data lake. So there's been this emergence of companies that are starting to emerge that overlay the best of both worlds. They're trying to wrangle the data, standardize the fields, make query logic into these data lakes a little bit more approachable to your SOC analysts, your junior analysts, but also the cost savings of the data storage. This is a little bit of a miscellaneous slide, but we also do see some interesting things going on at Cribble, right? So Cribble is detection in transit. So as when the data is coming from, say, CrowdStrike Falcon Data Replicator into your SIEM, you get a chance to take a look at that data, right? So streaming data, it's nothing's new running analytics here, but that's very interesting because not only do you get a chance to look into the data for malicious things, you're closer to the detection source, but also you get a chance to not save certain data, right? So you have this opportunity to tag certain data as let's store that in the SIEM or just drop certain data. And if anybody's ever hooked up to an EDR and ingested all of the things that it collects, there are a lot of logs that are not valuable that are collected. And that's actually one thing that we consult with teams is we can actually help them take, here are the threats, here are the detections that work against those threats. These detections are built off of these log sources. These log sources are built off of these finite fields. We find that measurement really helps customers understand what data their hunters will want to hunt against. And conversely, when you don't have a piece of data, this will say, hey, you're not storing this in your SIEM. You don't have this piece of data, so 20% of the detections for APT 28 are not gonna work because you don't have that log source. But anyway, talking about data, data priority and data persistence there. The other thing that's really interesting we see with Splunk is they actually have, right, you can send all of your data to Splunk, but they also have connectors out to definitely Snowflake, definitely Databricks, and probably some others. So you can use Splunk SPL query language with a single pane of glass, store your really hot storage, your warm data in Splunk, but then you can actually reach out to cold data lakes, bring back like meta queries that get pulled into Splunk, and then returned in line with results. So I think that's pretty cool. And then we already talked about like detection as code. The open source way of doing this is Sigma, and I just wanted to shout that out for you. If you have detections, if you have any SIEM vendor, there is Sigma. There are over 2,000 detections out there that you can run through compilers, port that to your data set, and run that. We do the much more professional, kind of very polished point-click test, make sure it works. But this is really good on the analytic layer to get started. All right, so let's see, future SIEM capabilities. All right, so we talked a little bit about detection as code. And so this is kind of lending itself into SIEM fortresses, right? So we run into a lot of customers that are either unhappy with their SIEM or unhappy with the price of their SIEM, and they want to trade off and move. One of the big reasons that SIEM vendors that we talk to have a challenge with is that they have existing workflows, playbooks, SOAR playbooks, but also their detection estate is very, very comfortable in one SIEM, and if they change, they have to change complete languages. Imagine if you lived in America and popped up and moved to China, you'd have to learn a totally different language. You'd have to retool your workforce. Things are going to be very unfamiliar. Same thing with SIEMs. So SIEMs have had their day, but I think with costs rising, right, like some of our customers, $10 million a year annually, we call it SIEM migration, is very, very important. So one thing that we see a trend towards is detection as code. And what that allows customers to do is to write detections one time and say, I want to describe this behavior of what I want to hunt for or alert for. And then if they have a multi-SIEM, so we have one large government organization, they have literally Splunk and Carbon Black and FireEye HX and Sentinel-1 and Microsoft Sentinel. Because large government organizations, you can't, there's not a lot of top-down, so each sub-team under this massive team has chosen their own SIEM, their own EDR technology. And so now they have this like fractional, SIEM fabric that they have to detect against. And when there's a latest threat, it's not like they say, oh, I only want you to hunt that big bad threat actor that's going after this government organization just on this technology. So what we're seeing a lot of companies moving towards is, how do we not vendor lock ourselves, all of the intellectual property, all of the detections that we're writing, how do we unlock that? And so there's a lot of good stuff coming out with mimicking what computer scientists have done for years in GitHub, the SDLC, the software lifecycle, software development lifecycle, right? Test, version track, push it out. If there's a change, how do you retroactively test, right? So detection engineer, 6 months ago, wrote a great detection. They're no longer with the company. How do you know how to make a change to that code that doesn't break the original intent of searching for that bad guy? Testing and validation. This is another thing that's real important with SIEMs. We're seeing a lot of SIEM vendors moving towards this, right? So I think there's going to be this consolidation of testing and evaluation of detection logic. Vendor after vendor after vendor we talk with, they have 300 to 1,000 detections, and they don't know which ones work. They don't know which ones don't work. They don't have unit tests for them, and poor documentation and things like that. So when we're talking about the data layer, the analytics layer of a SIEM, I think SIEMs, in the future, need to build this into their SIEM fabric, is testing, evaluation, knowing what a true positive detection looks like for that detection, and rolling that out into a CI/CD pipeline. The other thing that we see a big trend towards, everybody wants AI and ML to come and save the day. It hasn't for the largest part. I am a big AI ML believer, but I'm also a skeptic because I've seen so many people try and fail. I do think this is going to be on the bingo card at some point. It's going to be maybe 2025, maybe 2026. I hope there's going to be some really big breakthroughs, but I absolutely think with cloud native SIEMs, right? So we're talking about how do I store data in a very large and efficient way? How do I compute across that data? I think that has to happen because detection engineers just don't scale, and threats are just constantly evolving. So I think AI ML is absolutely going to be, it has to be critical. One thing I didn't put up on this slide is I also am a big believer. The last talk was talking about Bloodhound. For graph analysis, I think that there's a real opportunity out there for SIEMs to do log storage as a graph, right? So there's risk behavior analytics, RBA, that emphasize lots of small signals per entity rolling up to a bigger, badder, more scary alert. The problem that we have with this today is it's using joins, and joins are extremely, extremely expensive across large sets of data. So I think storing data, at some point there will be somebody that tries to store data as a graph, and that will eliminate the pain points and the complexity and the compute cycles needed for those joins, so that you can say, if this and this and this event correlate per entity, that's going to be an alert. And I think that'll be a major step forward for SIEMs. All right, so choosing the best. So here's kind of the overall roll-up before we start going to the next topic. So overall roll-up, essentially of what we found. The big things to talk about are integrations. Obviously, integrations coming right out of the box, right? That's what the SIEM is doing. Data lakes, they still need that other layer, the application layer, if you will, over top of it, making it more of a SIEM. Customization, obviously, SIEMs sometimes have their own workflows, their own experience that doesn't always work for what you need. So if you're building it out of the box, you can obviously have infinite customizability. And obviously, I think cost is about a wash from what we've seen. Really depends on your data set, and obviously a hybrid is possibly preferred, right? So having your security data that your SOC analysts are constantly going through in a SIEM, and then having things like very large data sets, credit card, transaction information, lots of things that I don't think are going to be queried every day, but have models around them, like storing that in some sort of a large data lake. But at the same time, you're going to have to pay for, your data lake or your SIEM. You're going to have to pay for it either one way or another. We did touch on migrations. Touched on migrations quite a bit, but when you're talking about, and this is something that we work with Google pretty heavily on, is how do we get customers to adopt a new technology when it comes to SIEMs? So you have to think about the data, the existing detections, and then that workflow. It's kind of like those three things. So existing detections is kind of our specialty. We're very good. We're getting very good at migrating language to language. I'd say like our first 2 years, we're very focused on detection as code, where you would start with the thing that you want to detect as code and then compile it down. Now with AI, LLMs, we'll talk about, I think, in the next slide, or 2 slides from now, is we're actually getting very good at doing language to direct language translation, which is going to unlock a lot of portability of knowledge, right? So if you write an amazing detection in Splunk and you want to go to Yara-L, how do you do that, right? It's the same problem as, hey, I have Farsi, a book in Farsi, and I want to convert it to Chinese, or I have a German and I want to go to Spanish. How do you do that language translation? That's some of the stuff we're working on right now. Today, when we work with customers that are on one SIEM and they want to go to another SIEM, they're really, really worried about their detection estate. How do they migrate from one SIEM to another, but not skip a beat, right? So professional services, we're seeing a lot of very slow professional services that are dragging out POVs. A lot of times customers right now have 6 months to 1 year where they're actually paying for 2 SIEMs at the same time as they start migrating over. Very, very painful, very, very slow. I think that'll become commoditized over time as data gets standardized, as fields get standardized, as detections get a little bit more abstracted. So we talked about AI in migration process, and so this is one of the things that we're actually, I would say, on the forefront of implementing with Google and some other companies out there. AI detection migration. So how do you go from German to Spanish? Really, without going too deep on this, customers really want, hey, I have this detection in this SIEM, and I want to go to this destination SIEM. So I really want this detection to go over here. There's quite a few steps that we pop through. So we have these SIEMs in our lab. Step 1 that we absolutely need to do is create a validation script. So given 300 detections with company A, how do we pump it through an AI LLM model to come up with a true positive test case that we know that will trigger that detection? And we do that for all 300, right? Now that we know what true positive looks like, we can go over to SIEM B and execute that validation system on SIEM B, and that will allow us to know what the finish line looks like for these AI models. Then the AI models can iterate, right? We have fine-tuned models per language, but we can iterate on this to create a new detection in the end language without any humans involved. And the big breakthrough is, you have to know what that finish line is, right? If you don't know where the finish line is, LLMs hallucinate, they try and cut corners, they try and cheat. So knowing what the finish line is absolutely important. So that's some of the stuff we're working with some partners. The other thing that I see, and this is maybe a takeaway for you, your SIEM, your migration, right? We saw a lot of breach attack simulations. We saw them kind of rise on that hype curve. I was super excited about it when that came out. Needing to test the true positive of your detection estate is absolutely critical in your SIEM. The things that can go wrong are so many. So we're talking about testing. You could have an attack, right? So the way to read this slide is, here's an attack, then here is the telemetry that is off-put by that attack. Then you have your logging tool of choice, right? Like your EDRs, your Sentinel-1s, your Zscalers, your CloudTrails. And then there's an attempt in most SIEMs to normalize that data. There's parsers that are involved, and those parsers break oftentimes in SIEMs, and we silently find them many times and reach out to the vendor to say, hey, you're not parsing this exactly correct. Then it's stored. Not very much goes wrong right there, but then you have your detection in your unique query language that goes to detect that. So if you think about it, from attack to telemetry to your logging tool to this parser normalization to storage to detection, there's a lot of things that can go wrong in a SIEM. So one way is breach attack simulation. Then you're actually creating an event on a Windows or a Linux host that is malicious, and then you try and detect that at the end. The other way that we're seeing that's very, very, very fruitful, a lot of challenges with very large companies being able to double-click on mimikatz.exe on a Windows machine or a Linux machine. They just can't provision the infrastructure. And it's kind of funny, like inversely proportional to the size of your company is how easy that is. We have small companies that are like, yeah, you want a VM? Like, here's your virtual machine, double-click on mimikatz. And then we have very large banks that are like, oh, that's going to be a 6-month approval process. Like, no way. But eventually, like, the goal is we need to test these SIEMs, like the data pipeline, the data engineering pipeline along the way. So what we're kind of working on is not creating synthetic logs, because synthetic logs would actually jump to the that would jump after the normalization directly to the storage layer, right? And you're kind of bypassing a lot of things that can go wrong with your field mappings, your normalization process, your standardization, your parsing. So what we're working on is actually creating the actual events that will trigger on those endpoint or cloud systems that get naturally collected by the logging tool, naturally parsed, naturally stored, and naturally detected. So we're kind of almost like just skipping this one step. Now, no doubt there's breach attack simulations like definitely have a role in this testing evaluation of SIEMs, but yeah, this is a very interesting, promising future. So we kind of talked, and this is kind of the last slide because I know I'm the last person, so I didn't want to like take up all of your time. So if you're still stuck in traffic, you can hang out. There's Wi-Fi, there's air conditioning. Hang out. I'll be around to chat. But I didn't want to go too long here. But the key takeaways, right? So we talked a lot about like the SIEM history of where they came, where they evolved, the 3 different phases. We also talked about the need for future-proofing SIEMs, right? Going to the cloud, and then I think there's a future there where data fabric is cloud native, right? But we have to get there with acquisitions to make these SIEMs in the cloud as easy to use as the SIEMs we have now. And then we talked a little bit about migration, right? So as people move from SIEM to SIEM, what are some of the pain points? What are some things that you can do to alleviate those pain points? So yeah. All right, and that's it. All right, that's all I have for you guys. I hope you guys enjoyed MWise. I hope you had a great conference. It was excellent catching up with so many faces. A lot of times we're not in person, so hopefully you took the time to network and meet people. And that's it. Thanks.